This is probably a more technical question. This has been pseudo-technical already.
Okay.
But it's about traffic modeling in the city, or I guess anywhere. And the traffic modeling that's, I guess that people do, when there's proposed changes in roads or things like that, people run traffic simulations to see what happens in those cases. And it seems like a lot of the simulations, the results you get are very dependent upon the assumptions that go in your models. What assumptions do you think are necessary to make sure that these models are good, and how do you work to ensure that the models that people use are really predictive in nature?
The models that we use now are really very limited. They're limited to traffic volumes and then density, and then you insert the signal timing, but it won't make any judgments in terms of the traffic that might shrink as a result of less circulation, or people traveling at different times, or people switching modes. Those are the kinds of things you have to manually input into these models, and then you have to have the courage to stand up and say that you're confident that we're going to 5% of the traffic just isn't going to be there even after we remove this particular road or this particular lane, or traffic will divert to some other routes. I'm in battles like that right now. I'm in the west side of Manhattan, the boulevard that's being built between the World Trade Center and the World Financial Center. The plans are for it to be a full 10 lanes to get across. And that's way too much for New York City. And I propose to make it 3 lanes in each direction and 1 additional lane for turning. So 7 lanes versus 10 lanes. 36 feet less for a pedestrian to get across. And because of that, the signal timing will allow a pedestrian to get across in 1 crossing instead of what the state plans, 2 crossings, which will take 5 minutes to get across the street. New Yorkers aren't going to stand for that. They're just going to run across and create a dangerous situation. The state model says you have to include every single vehicle that's there, and that, what I propose, will cause massive traffic jams.
So the state model says, as part of the state model, you have to just assume that all those cars are going to be there.
That's right.
Even though, in your experience, the Miller Highway falls down, those cars somehow disappear, they're saying cars don't disappear at all.
That's right. And they will use all of those vehicles and keep all those vehicles in the system, and then they'll say, well, you're backing it up to the George Washington Bridge.
And so when you say the state model, is there some sort of official guidelines that the state has for how you're supposed to do this?
The state puts out manuals that are literally that big, and I don't know if they have a particular rule about that, but the rule is that you must include all the vehicles. You must present a worst case analysis, and the worst case analysis always means let's provide more lanes in order to provide an adequate level of service. That's the guideline. So to provide level of service, C, traffic engineers, grade highways from A to F, and try to keep it within the C-D range and never go to E or F. To demonstrate that you're going to be at a C or D, you may need more lanes. When people with experience may be able to say, we can get by, we can push it to a DE, and it really will end up between C and D because people will divert or change time or change mode.
This whole modeling process essentially dictates that they demand that you just keep building extra lanes, even when history has shown that that's not something that works.
The problem is that the levels of service they apply to cars and rarely to pedestrians. So the pedestrian, which is, to me, the dominant mode downtown, is walking. If you had to add up all the trips people take, and that could include the trip to go out to lunch, and then from lunch back, people walk. They don't get in a subway, they don't get in a bus or anything like that. The trip, so many dwelling units are now in downtown, or the Tribeca or Soho, people walk to work. So again, walking is the dominant mode. But when the calculations are being done, calculations for pedestrian are almost non-existent. I was shocked to learn when I started to call it pedestrian engineering, not as a pejorative, but engineering for pedestrians, that nobody had trademarked it. So I trademarked it. But every book has been written about traffic engineering, and I'm in the throes of writing a book called Pedestrian Engineering.
Well, that's good. The world could use that. So, well, right now there's something called pedestrian level of service, which is analogous to automobile level of service. And I guess when they're considering making some change to sidewalks or something, that's the standard which gets applied. There are similar sorts of models that calculate how many people are capable of fitting down a sidewalk and things like that. But people are different than cars. Cars, there's basically the only thing you can do is drive or park. I mean, and pretty much driving is the only thing that people really care about. But people, are capable of doing a lot more than just walking down the street. They can stop and talk, they can hang out, they can drink, coffee by the side of the road. And it doesn't really strike me that the pedestrian level of service methodology takes into account the full level of human behaviors. It strikes me that they almost want to pretend people are mini cars and look at them that way, rather than sort of say, these are people. What happens on a sidewalk or on a street if you really just observe what people do?
Yeah, there's so many benefits to having lots of pedestrians, and not the least is safety. And having lots of activity on a street usually means that street is much safer. But even when the engineers, the traffic engineers, not the pedestrian engineers, assign levels of service and treat the pedestrian almost as little vehicles, they don't do what they do for cars. For cars, they introduce delay. Pedestrians, they never calculate the delay that it takes to get across the street, that the pedestrian was waiting for 2 minutes to get across the street, and therefore 120 seconds of delay. But God forbid there was 60 seconds of delay for a car, then we've got to fix everything.
There is actually federal law that says you don't have to do things according to the typical highway engineering guides. And so that when people are trying to do things in their neighborhoods and they want to do something that breaks out of this mold, there is law that says you're allowed to do that. Is that the way things work?
I was the chief engineer for the New York City Department of Transportation. So I had the authority to use engineering judgment, which I did many times, to do something differently than what is in the Federal Manual of Uniform Traffic Control Devices, or what is in the Green Book, or under AASHTO, which is the American Association of State Highway Transportation Officials, guidelines. There is this waiver that if you can use engineering judgment as a substitute for a guideline. Now, there are hardly any officials that, one, have the capability of being able to discern enough to have engineering judgment or have the courage. Most of them will hide behind the wall of saying, well, what if we get sued? We didn't follow the manual, and that they would have to testify in some kind of lawsuit that they didn't follow the manual. So the safest thing is hide behind the manual. If it appears in the Uniform Traffic Control Devices, if a lane is 12 feet wide, if a shoulder is 10 feet wide, if sidewalks have to be a certain design, we're going to hide behind that and use that. But you don't always have to follow that.